So we're continuing with cables. Now we have been dealing with cables we deal first with cables that have pointed loads. We were able to calculate the maximum tension in the cable. We were able to calculate the length of the cable. These are the factors we need to be able to design a cable. Now we have been able to also to get maximum tension in a cable that's carrying a UDL. We're getting minimum tension in that cable. That's what we just did. Now, the next thing we want to do is because in the cable that was carrying pointed loads, we're able to get the length of the cable. Length of the cable is different from the span of the cable. The length of the cable, because it is that length that will enable you know how far the cable will be that you're going to recommend for the work. So now, for the cable that's carrying a UDL, after rigorous analysis, we got that the length of the cable is equal to S is equal to L plus 8. So the sag is F. F is the sag. F squared over 3 times the span. So any cable that is loaded with a UDL, the length of the cable is this here. The length of the cable here for this first one, cable A, this cable B. For cable A, the length of the cable is S is equal to the span is 12 plus 8 times the rise. The rise is 2.5. 2.5 squared over 3 times 12, which in this case I got it to be equal to 13.39 meters. 13.39 meters or 13.39 meters. That is the length of a cable that has a span of 12, that's to cover a span of 12 meters and is carrying a uniform distributed load with a sag of 2.5. This is the length. For this one B that is to cover a span of 18 meters and having a sag of 3.6 meters, a sag of 3.6 meters, the length of the cable will be the span, which is 18 plus 8 times the square of the sag, which is 3.6 square over 3 times 18, which I got to be equal to 19.92 meters. 19.92 meters. So I've been able to get the length of cable required to carry a UDL over a given span. In this case, over case A, over a span of 12 meters, and has to sag to a depth of 2.5 meters. So, and the length of the cable that will be required is 13.39 meters. For cable B, which is going to cover a span of 18 meters with a sag of 3.6 meters, the length of cable that will be required is 19.92 meters. So that is that whether the cable is carrying uniform distributed load, we can get the length, we can get the maximum tension which we use to design the cable. If the cable is carrying pointed loads, we can as well get the length. We can also get the maximum tension or minimum tension if that's what we want to design the cable. Thank you very much. That's the end of this episode.